we're gonna, I first want to mention that in the chat link is in the chat box is a link to a Google Slides that we will use for most of this workshop and talk today. You should be able to access it. All the materials are there. And in a couple minutes, I will turn it over to the students to present to you some scooter micromobility related planning work that they did as part of a semester-long, what we call Musa practicum. And that is an applied data science project that the students work with actual governments on. And at the end of this presentation, at the end of our workshop today, I will try to convince you that you should work with our students next spring. And I think you'll see how much value there is that these students can create. And I kind of want to motivate their work by sharing with you a little story. So these students pulled together what existed or incentivized 5 or 6 cities to release scooter data. It was their first open data releases of scooter data in many of these places. And there was one smaller city that was interested in working with us. The city will go unnamed for now. And this city has entered into a license agreement with a company for their MDS, their scooter data, that this company would store their data for them and present it only in the form of a dashboard, but not as raw data. And the city reached out to them and said, hey, we would like some of our own data so that we can participate in this open source project with these students. And the company told them, I'm sorry, you've given us a license to your data and we cannot share it back with you. So the data that belonged to the city, not only was it not permitted to be open data that communities could use, but the city apparently was not able to use it for their own operational decision making. And I've seen this happen many times before, and we think that open data is, the fuel of much of the evidence-based public policy that is happening today. But we believe in an additional layer of that, and that is this idea of open analytics, the idea that many of us on this call, many governments, all share the same set of use cases. They need to do the same thing, answer the same questions with their data. They all collect similar administrative data. And through this community of civic technologists, of academics, of planners, of you folks, it is, as you have seen, now possible to generate technology for free that can permeate through all of these diverse user groups. And we call that open analytics. And it is really very much at the core of what we practice in the Musa program. And so if you go check out the third slide of that slideshow that I sent, you will see, actually, I'm sorry, in the top of the agenda, you will see on the second slide, a link to the Musa Practicum website, where you can see all of the open analytics projects that we have built for governments over the last 3 years, ranging from housing community development to transportation to public safety, environment, onward. And our goal is to, while we believe in the ability and the right of businesses to contract with cities for these services and these products, we just feel like as data science and technology becomes more a requisite in government, that there is more opportunity for communities to come together to develop these projects and make them sustainable on their own. So in a minute, I'm going to turn it over to Eugene and to Ophelia, who will show you one of these projects around micromobility. It was an incredible amount of work that these students and a third student, Shini, who is back in China, unfortunately, cannot join us today. She's sleeping. But you will see the breadth of work that these students did from collecting these disparate data sets and building a whole host of really actionable operational decision-making tools. After that is done, we will come back together and we will break into 3 groups to begin this workshop. And the goal of the workshop will be to try to develop some dashboards, design, conceptually some dashboards that might help us answer some shared use cases or planning questions that we all might have. I'll provide a little more depth of that after the students. And then we'll, for the last bit of the workshop, we'll come together and each group will report out. All right, then again, I want to thank you all for joining us. And again, to Nicole and Yadira and to NACTO for having us here. As Michael mentioned before you all got on, we love as educators to have our students' work be recognized. And I think you'll find that the work they've done is just far beyond what you'd expect from some students. And so I'm psyched to have you all see it. And without further ado, please take it away.
Hello, everyone. I'm Eugene. I'm here with my classmate Ophelia to share a project we did this semester on analyzing scooter equity and demand in several American cities. I'm just going to share my screen. All right, can someone give me a thumbs up? You can see that. Excellent. Okay. All right, so just a quick agenda for what I'll be presenting today. I'll be doing an introduction to scooter share systems in the US. Then I'll hand over to Ophelia, who will introduce the wireframe app we put together for this project. And then we'll go back to the slideshow to look at the prediction and equity of access analysis that we did. And then we'll do a deep dive into the rebalancing data and compliance in the city of Louisville. So since Bird and Lime launched the first shared dockless electric scooter system in Santa Monica in 2017, scooters have rapidly spread across American cities, and they become a very popular form of urban transportation. Currently, there are 340 scooter share programs operating in 242 municipal areas and campuses across 40 different states, plus Washington, D.C. In 2018 alone, users took more than 38 million trips on electric scooters, which is actually greater than the number of trips taken on traditional station-based bike share systems. At the same time, municipalities are increasingly overseeing these programs, facilitated by data tools like the Open Mobility Data Standard, which helps cities share and monitor scooter ridership data and make sure that providers are complying with their policies. However, while some cities like Louisville have instituted requirements for equitable distribution, not all cities have done so. And as we discussed later, scooter companies are not necessarily complying with these distribution requirements anyway. More importantly, there are no widely adopted models or standardized guidance in place that help cities without shared scooters introduce the vehicles or a scooter oversight program into their markets. So we conceptualize our project as a municipal scooter planning toolkit that would help cities interested in launching scooter share systems or interested in adding some additional oversight, learn from other municipalities that have already put these systems into place, anticipate the geography of scooter ridership in their cities, and then see how it compares to the city's social and economic geography. So I'll pass it over to Ophelia, who will share her screen and go through the app that we created for this project.
Okay, can you guys see the app right now? Okay. Thank you. Thank you, Eugene. And thank you all for having me here. I'm Ophelia from the music program in the University of Pennsylvania. So now we're going to take a look at our web application. So this is the navigation page introducing our project and the team. To start exploring our prediction, we will select the city from here. So let's say Philadelphia. So right now, larger. Right now we're looking at Philadelphia, and the map is showing the predicted scooter ridership at the census tract level. So on the sidebar, drop-down menu, in addition to the predicted scooter trip, we can also select other variables such as population, number of jobs, median household income, to visualize it on the map. The table here provides an overview of the city in terms of its demographic and socioeconomic characteristics. And the scatter plot below shows the relationship between the selected variable and the predictor scooter ridership. When we change our variables, such as this, the scatter plot will also get updated as well. And let's go back to predicted scooter trips. So on the map, we can hover on the tract and we can see the number of predicted ridership on the top right corner over here. And not surprisingly, we can see lots of trips concentrated in University City, and Temple University over here, and the Center City areas. And we can also click on it to zoom in, and we can see the map underneath it. If we keep zooming in, we can see the place tags such as universities, hospitals, restaurants, theaters, retails, or offices to get an idea of what's going on over there. So after we click on the tract, the table will also get updated as well, showing the information of the selected census tract. And the point associated with the selected census tract will also get highlighted in the scatter plot as well. And we can always click on reset table and reset zoom to go back to the initial state. And here we also included an equity score, which roughly measures the level of equitable access to scooters across the city. And Eugene will elaborate on how we calculate this score later on. On the navigation bar, we provided a quick tutorial on how to use this tool, and we can change our city over here. So for example, this is Asheville, and this is Jersey City. And we have, for example, Houston over here, which is pretty huge. Yeah, so, and we can always go back to our homepage, clicking on the button. So that is a brief overview of our application. We will go back to our slides and I'll walk you through our data analysis process. Eugene.
Yep. All right, thank you, Philia. There we go.
Yeah. So first of all, we aggregated the total number of scooter trips taken between July and September of 2019 in each census tract. The maps are showing trip outflows at the census tract level, and it can be observed that scooter trips tend to concentrate in the center city areas. We collected our training data from 6 cities that had scooter experiences before. The cities are Austin, Chicago, Washington, D.C., Kansas City, Louisville, and Minneapolis. Next slide, please. We are aware that these 6 cities we've chosen vary greatly in size as well as in demographic and socioeconomic features. We picked our predicting factors from census data and from the built environment. Some of these variables are generalizable across different urban contexts, while others reflect some differences among the cities. So for example, we can see that there are more variations in the percentage of white and minority census tracts in Chicago and DC compared to other cities. Next slide, please. Similarly, these 2 cities have a more intensive public transportation network, so that the percentage of people taking public transit to work is much higher, and the average commuting time is much lower too. During the feature engineering process, we experimented with variations of the built environment variables, and the ratio performs the best. So for example, the ratio of restaurants stands for the percentage of the city's restaurants located within that particular tract. And we plotted the number of trip count in each census tract against some independent variables. And among all of the predicting factors, we saw jobs and some built-in environment features such as restaurants, offices, and public transportation stations are closely related to scooter ridership in each census tract. Then we move on to build our machine learning model. We tried 4 different model frameworks, including linear regression, generalized linear framework, generalized linear model, XGBoost, and random forest. We also conducted cross-validation and model tuning to find out which model performs the best. And our final model is the random forest model. And next, we show an example of the predictions and prediction errors made in Austin, where the model is trained on the rest 5 cities. We can see large errors in the center of the map, suggesting that our model tends to underestimate scooter ridership in center city areas. And then we selected 10 pilot cities without any scooter experiences before and applied our model to predict scooter demand in these 10 cities. They are Asheville, Jacksonville, Hartford, Houston, Jersey City, Madison, Omaha, Philadelphia, San Antonio, and Syracuse. So now I'll pass it over to Eugene, and he will talk a little bit more about the equity score we mentioned before and give a brief introduction about the rebalancing compliance in Louisville. Thank you.
Thanks, Filia. So as you saw in our previous maps, both actual and predicted ridership are heavily concentrated in commercial downtowns and near universities. This reflects both the high underlying demand in those areas, but it also reflects company deployment strategies and decisions. Ridership will be high in places where people want to ride scooters and where companies make them available. As a result, people living outside of those areas have or will have insufficient access to scooters, meaning this new mode of transportation that's becoming such a prominent part of life in some cities is not available to many people. Cities will be interested in understanding which residents and which parts of cities have access and which do not. To this, we propose an equity score, a simple metric for measuring the equity of accessibility for an existing or prospective dockless scooter system. Put simply, we compare the percentile rank of various socioeconomic indicators between areas with high ridership and areas with low ridership. Here, as an example, we look at income, percentage of population that identifies as white, and median age. But the benefit of a straightforward metric like this, and one that's easily interpretable, is that cities can easily modify the indicators they look at to fit their policy planning priorities. As you can see on the table on the right, our equity scores tend to be significantly higher in the prediction cities. And we believe that this goes back to something Ophelia mentioned, which is that even though our model predicts high ridership in downtowns, it still actually underpredicts how skewed that distribution is. And with some further model tuning, we'd expect that we'd be able to generate predictions that have as high ridership in those predicted cities. Another element of this score that we'd like to look into further is if we can figure out in any way while we're looking at the distribution of access in a geographic area, this doesn't look into who exactly is riding the scooters, just because the vehicles are available in areas across this socioeconomic or demographic grounds does not necessarily mean that a diverse array of users are actually riding them. All right, now I want to do a deep dive into Louisville's rebalancing compliance. So in response to vehicles being concentrated in certain areas, some cities have instituted distribution requirements on their providers. Providers are required to rebalance their vehicle fleets to areas where the city would like to improve access to vehicles, but where the providers might not send vehicles if they were not otherwise required to do so. Louisville is one of those cities. As we see from their policy statement listed here, the goal of the policy is to improve access to scooters in certain parts of the city and boost the overall equity of the system. There are some additional details to the implementation of the policy, including which providers these rules apply to, but the main takeaway is that providers must maintain a certain percentage of their active fleet within several distribution zones at all times. So Louisville shared their rebalancing data with us. Unlike the other data sets we looked at, which came primarily from publicly available open data sites, these data not only include exact coordinates for each pickup and drop-off location, but also includes non-user events like vehicle maintenance, new vehicle introduction, retirement, and of course, rebalancing, where the company moves a scooter from one place to another without a user taking a ride. However, this is flow data. It tells us when a vehicle moves, but it doesn't necessarily tell us where every vehicle is at any given time. A vehicle may be available in an area on some day at some time, but if it hasn't moved recently, it's hard for us to know from the data. So the solution we came up with was to track every vehicle in the data set up and check its last movement up to a certain audit time. This way, we know if a vehicle was available for pickup at a certain time, and if it was available, where it was located. One thing we also found was that some vehicles were available, but then they disappeared from the data entirely. These are vehicles that got removed or retired from the fleet, but they weren't recorded as such in the data. So once we took our flow data and then converted it into its audit form, here's what our new data set looked like. On the left, you can see an audit date, which shows the date and time that we took a snapshot of the vehicle fleet in Louisville. The next column shows the operator, and the column after that shows the total number of vehicles that that operator had operating on that day. And then lastly, we can see a breakdown of each vehicle in each distribution zone across the city. So we decided to audit the fleets periodically to see if the companies were complying with Louisville's rebalancing requirements. During our exploratory analysis, we saw that most rebalancing happens late at night and early in the morning. So we decided to take snapshots of the fleet at fixed intervals at 7 a.m. when the company is most likely to be in compliance. And we checked where every active vehicle is located. We found that during most of our audits, the operators were not in compliance. On the chart to the right, the bars indicate the percentage of each operator's fleet located in each distribution zone, and the red line indicates the minimum percentage required by the distribution requirements. We found that most of the time, the operators were not in compliance, with only 2 observed cases where a provider had a sufficient number of vehicles in a zone. One caveat to this analysis is that it isn't clear from the data alone when the distribution requirements took effect for each provider. In Louisville, the requirements are tied to the size of each operator's permitted fleet, not necessarily the size of their active and deployed fleet. And it wasn't apparent from the data when their permitted fleets reached a size that made the rebalancing requirements take effect. However, just looking at the last few months of 2019, all the way on the right to the graph, where we know that the requirements did apply, we can see that the providers were not complying. Rebalancing policies can be an effective way to improve the accessibility of a system, but additional monitoring and enforcement are necessary to ensure that they have their intended benefits. Here, we've presented a quick methodology through which cities can transform their vehicle flow data, which shows where fleets are currently moving, into vehicle fleet audits, where every vehicle is right now, to aid their monitoring of rebalance compliance. To conclude, scooter ridership reflects both the underlying demand for the vehicles in an area or neighborhood, but also the distribution choices and city policies that make the vehicles available or unavailable in those areas in the first place. We produced a model that predicts peak season ridership in new cities based on the experiences of cities with existing systems. Ridership tends to be concentrated in downtowns and near universities. We then proposed a simple equity score metric, which allows cities to quantify the equitability of existing and prospective systems. While we looked at census tract incomes, racial makeup, and median age, this metric serves as a framework that can be easily customized by cities as necessary to fit their planning and policy priorities. Lastly, we took a deep dive into Louisville's rebalancing data set, which showed that providers are not currently complying with the city's requirements. We believe that these distribution requirements can be effective tools for increasing access, but monitoring and enforcement are critical to obtaining their full benefits. We provided a methodology in our technical report that cities can use to convert their vehicle flow data into vehicle fleet audits for monitoring these requirements. Thank you very much for your time, everyone. We're happy to take any questions you may have.
Thank you all so much. If you all have questions, please, I think the easiest thing might just be to paste them into the chat. You know, I just want to say, just reiterate again how proud as educators we are of work like this, and it also but their work is open source and available on the Musa Practicum website, which is linked to on the slides we'll be using for the workshop. And so if you have someone who is used to working with MDS data and in R, you can copy and paste the code that they have put up there and replicate a lot of these analytics, and in particular the one about compliance, which is a great example of a shared use case that that cities across the country are going to need to audit their scooter companies. All right. If you have a question, you want to turn on your video and your mic, you can also do that as well. I was teaching all last semester, so I'm used to a grid full of black screens. Hi, Kyle. How are you?
Hey, how are you doing? I am the staff data scientist for the bike share program at New York City Department of Transportation.
Welcome.
I had 2 quick questions, if I could remember them now. One I guess was more of a comment. So you said you had trouble figuring out where the actual devices were at any given time. You had the movements, but you didn't know if they were still actually there. Were you doing all this retroactive, or did you think about taking some data from the GBFS feeds that has the real-time location of vehicles?
We were working from a snapshot of data, so it was all retroactive.
Okay, yeah. So I mean, I know that there's some issues still with GBFS in terms of privacy and being able to do trip inferences with truly stationless micromobility services. But at least for a long time, you could certainly go and figure that out. I mean, the other thing too is these scooters sometimes tend to walk a little bit, and I don't know if I don't know necessarily if some of the dockless stuff ends up being perfectly reliable, but it certainly is at least corroborating evidence of where a vehicle might be. The second question I quickly had was for the equity scores that you were actually doing for those predicted cities. Those are based on the underlying predictions of where you think that scooter demand is that right? And you're just calculating that off of the different features of the different census tract data and things like that?
That's right, yes.
Why do you think that all of those predicted scores were on the upper, if not outside of the range of all of the data for cities that you were using for training?
Yeah, so one challenge was that if you look at cities that have like actual systems in place, the distribution in terms of census tracts is extremely skewed. Like 10 to 15 tracts will have like 90% or more of the rides. And our model tended to produce a flatter distribution. So I think it's a matter of model tuning. And because it produced a flatter distribution, I think that the predictions ended up being less skewed, and they were shown to be perhaps more evenly distributed across the city than they would be in reality. So I think that was just a limitation of our model that, you know, we were working with, but just as a matter of time, like that's the closest we were able to get it to matching the distributions we observed.
Yeah. And I guess just one other really quick question is for the final model that you were actually using, that random forest model, how many input features did you use?
I think it's 20 plus labels we find as the final predicting factors we put in the model.
Okay, thank you.
Thank you.
Thank you, Kyle. Is there one other question? If not, we can move on to the workshop. All right. For this workshop, it is it will be, I don't think it's reasonable. I don't think it's possible to interact with the workshop if you're not on this Google Slides. And you can find the link to that in the group chat. What we're going to do here is to try to build some wireframes. So all of you, I'm sure, are using dashboards or have ideas for like your dream dashboard. And I want to give us all a chance to explore what your dream dashboard is. So what we're going to do is we're going to split into 3 groups. One will be led by myself, one will be led by Michael, and the third will be led by Eugene and Ophelia. And we're going to try to first have a discussion about what are the kinds of operational and planning questions related to micromobility that you would like to see addressed using data. We'll try to understand what the current decision-making process is. Do you use data to address those problems now? If so, what are the limitations, etc.? We'll try to understand who the users are of this dream dashboard and what the data sources are. And then we've prepared some, like a template. We'll be able to move around to try to create a little mock dashboard for your use case. And again, the idea is that all of these cities have these same shared use cases. And so if we can develop a really strong open source and free dashboard in one place, it can be replicated and used in all the other places. So we're going to test the extent to which we all do actually have some shared use cases. I want to make one other note that I'd like you to focus on. So some of the existing companies that are providing micromobility dashboarding tools, those dashboards are really amazing. But I'd like you to consider when something happens like a pandemic all of a sudden. And now you have questions that are related not only to mobility, but also to public health. It may be difficult or timely for those companies to roll out new features that would allow you to, for instance, integrate data from the public health department with your MDS data. So it's more challenging, but we find that the hardest problems in government to solve with data are those that require a myriad of data use agreements and logistical planning across agencies to share data. So some of the use cases I'd like you to think about are those that do in fact require across agency data. So we'll all jump into this. Again, please move over to the Google Slides. There is a set of slides and a wireframe for each team. So you will see whichever team you're assigned to in the breakout room, navigate to their slide. And then we'll try to take 35 minutes-ish for this. So we'll try to come together with some time to report out at that time. So again, I urge you to think outside the box. This is your dream dashboard. I thought we had a really great conversation in our group. We have 3 breakout rooms, and therefore 3 sets of answers to questions and some mock wireframes. We have 23 minutes, so I think I'm trying to think about 5 or 6 minutes per group. I will start. We'll go in order. I think there's some conversation to facilitate here. Frankly, I wouldn't be mad if we were going through this and someone brought up an idea for an approach, a dashboard, and then we just spent the rest of our time talking about that one use case. The whole idea here is to spark some creativity, to create some technology to solve a problem. So if you have something to add, please feel free to interrupt or chat us up. So we do this exercise all the time when we build technology, and it starts with like in a very non-technical way, trying to understand what the problems are and if the data will help solve some of those problems. So we identified a slew of them. I'm on slide number 4 if you want to read along. There were a few people who cited equity being a big concern, and particularly trying to identify areas where there were riders who didn't have access to automobiles, where they could access micromobility options. And in that regard, it's not only just about trying to understand where those riders are, but the community assets available to them, such as schools and rec centers, et cetera. We talked about special events management. So we had a representative from Austin, which obviously deals with South by Southwest, where everything gets turned on its head for a few weeks. We talked about congestion, and we heard from a representative in LA, which is really at the fore of this kind of innovation and digital parking spaces. We talked about rebalancing and demand prediction. And then, once we try to understand what the need is, then we try to understand what the decision-making process is already. So, we heard a number of different ways that some of these equity issues, some of these planning issues play out. It started with a lot of you, I'm sure, contract with third-party vendors. There is a couple folks who said that they do in-person audits to make sure of compliance. And we talked a bit about whether some of these third-party vendors, some of these software as a service providers will actually do some of the kind of compliance that you saw Eugene and Ophelia talk about. And I think it was in LA talked about a task force, like an emergency task force with the scooter companies, between the scooter companies and the city to try to address pressing issues. And we listed a number of potential data sources, not only around transportation data, but also around demographics like census data, schools, Vision Zero data related to crashes and speed limits and street-related inventory. And then onto slide 5, the slide that we tried to take on the equity use case. And so we tried to think about some radial buttons on the top left, where you can see, for instance, in blue, those circles are my idea of a very quick hotspot map. hotspots for where scooters were currently being served, and then in red, where we think that there are populations who would likely use scooters if it was provided for them. And then there is inevitably a misalignment. So a proper alignment would be places where we think that demand exists and is actually being served. So we'd able to be able to identify the gaps, which is communities that we wish had access, and where and whether or not that access is being provided, and geospatially, like at the community level. And for those of you who are working in bike share, many equity initiatives did just this, to map the communities that are underserved and think about opening up stations there. I know in Philadelphia, that was a huge initiative, and I feel like Philadelphia is a leader in doing this kind of work. But scooters, as you know, are much different because they're dynamic and because these companies have say over where their scooters are balanced. And if we could understand, for instance, we could start scoring places as that they're served or underserved, and we can compare across groups and set some milestones for these scooter companies, and finally develop a piece of technology that would send almost like deployment plans directly to the scooter providers to say, these are the places that you need to focus on. And the data would make that kind of back and forth communication efficient. I'm all about community engagement. I'm all about getting companies and the city in the same room. But I know if there was a shared dashboard, a shared resource like this, I think it would facilitate more planning between the companies and the city, and it would set the goals and objectives right there in black and white for the companies, and provide a progress report back to the city about the extent to which the MDS tells us that the companies are living up to those set objectives. So this is our basic wireframe, and this is what we did with the students, with all the students that we work with, and we would then, after we design it, we would then start writing some code. So I will turn it over to Team Michael.
Good afternoon, everyone. Our group had so we're on slide 6. Our group came up with several very good use cases, which I sort of deleted here for the purpose of clarity, just with the current use case that we went forward. But we had a use case related to essentially predicting where there were broken vehicles in a scooter fleet. And then 2 very similar ones, which related to demand predictions and trying to come up with site selection kind of criteria for streetscape improvements and corrals for scooters based on demand and the width of sidewalks and the streetscaping characteristics of a given area. And then another one, which we fleshed out a little more, which was about identifying opportunities for mode shift to bike share. And in this use case, the sort of business as usual approach, which hopefully a more analytic oriented approach is hypothetically going to replace, is sort of a path of least resistance ad hoc thing where there are opportunities to maybe put a bike share station. There's projected to be, not very much trouble with necessarily getting it built. And it's a little bit ad hoc and somewhat anecdotal, based on anecdotal information. So the SFMTA is sort of the guinea pig user here, but this could go for any number of similar agencies and programs. And the outcome that we focused on was the change in utility brought about in a given area by switching to bike share, right? So there's the propensity, given a projected amount of demand, if you put a bike share station in something, in some area, what is the sort of change in the utility to people's lives based on their relative income, where they can get to in terms of their home, place of employment, so on. So the mechanics of doing this aside, because it sounds like a challenging proposal, we came up with a dashboard, which is on slide 7, which is a mode shift utility prediction dashboard. And it allows you to do 2 things. First is to zoom in on a particular area if one were to choose whatever the unit of analysis we would decide on, be it like some kind of grid cell or a neighborhood or a census tract. You can zoom in on it and look at the projections for that area in, over the course of a day, over the course of a year, whatever it may be. And you can also look at a bunch of characteristics of that area to see if the broader policy goals in terms of locating bike share and the populations that need to be served are being served in this area, right? So you can click on it, you say this has a dark red color, it has a lot of utility here, I'm gonna take a closer look. But you can also rank all of the areas for which there have been predictions by a number of different criteria, including the commute times from the ACS, the relative level of inequality in those areas as compared to the metro area, the supervisory district, this being San Francisco, so the political jurisdiction, the density of crashes, other things about the safety environment. This will give you sort of a composite set of metrics to figure out whether this place is where in fact you want to place a station. So this was really this is a real speed exercise here, but I think that there's a lot that was put out in a short period of time. So hopefully we'll do this again sometime. We'll get to those other use cases, which were great indeed. Eugene, Ophelia, let's hear about your group.
Sounds good. So we had a good conversation as well. We had people from Austin, Baltimore, San Antonio, Philly, and Tampa. And I might have missed one in there in the group. And they all have some similar concerns, but also that are specific to their cities. So speaking on some of the data challenges, more generally, I think some of the problems are that the data typically comes in a more static form. It's harder to do any real-time analysis, partially because of the data coming in, just not being amenable to that, but also just as a matter of reasons, not enough data scientists or data analysts on staff to process the data at the speed and volume necessary to really get like a clear picture. There are also some concerns about different providers providing data that basically doesn't talk to each other. I think Joseph in Austin mentioned that they have a dashboard that sort of combines data from 2 different providers on top of each other so that they can, I guess, see more clearly the discrepancies in the data, see what types of outliers or broken data points one provider is subject to compared to the other. And then there are also some concerns about privacy and data security. I think Meg in Baltimore mentioned that their data is run through Populous, partially because they do provide good metrics and dashboards and support for them, but also because they handle a lot of the data security issues. Baltimore went through a ransomware attack last year, and there's of course concerns that if they were to house all this mobility data in its raw form on city servers, they might not be able to protect it as well as provide its business. And then there was also some questions of standardized or easy or best practices, easy ways or best practices for categorizing stations. So station-based systems, of course, have stations located in different types of areas, whether they're residential neighborhoods, campuses, downtowns, or stadium districts, things like that. And a more consistent methodology, perhaps across cities, for categorizing these would be nice, so that one can understand in a given city what percentage of access is available in these types of areas, things like that. And then, of course, the challenge becomes even harder when you're looking at Populous systems, because there are no stations to which to anchor. So you have to choose an area of aggregation and do these aggregations at a much higher level with more data. I think we can move on to the wireframe. So on slide 9, we didn't really have a single organizing use case. I think we went through a lot of things that people appreciate from the dashboards they currently have. and things that they would like to see. I think one that everyone agreed on is some sort of way to do dynamic geographic aggregations. So at the moment, typically dashboards, like the one actually Ophelia and I presented, are centered around a single geographic unit of analysis. We looked at census tracts, and I think the one that was mentioned also looks at census tracts, but it would be nice if you could draw a box of any size in a city and automatically aggregate a certain number of summary statistics or variables as it happens. And so I think that was one that people would love to see. I think two interesting use cases that are brought up were rolling windows to track idle vehicles per provider. So I think Joseph and Austin mentioned that they try to use these sorts of like rolling windows to see what percentage of vehicles have not moved in the past X days as a way to sort of infer whether the providers are complying with their rebalancing to the extent that they suddenly have a spike where they never move any vehicles relative to the typical day. You might be able to infer that the provider is not doing what they're supposed to. So an easy way to see that, or at least create some sort of rebalancing metric would be really helpful. And I think another one that was brought up was Calvin from Tampa, and he got cut off because the breakout room ended as he was in the middle of speaking. So please correct me if I'm misrepresenting this, but he would love to see a clearer picture of offline vehicles. Tampa charges their providers for every online available vehicle that's in the right of way. So it's like the charge per vehicle for taking up space on our streets. But if I'm understanding correctly, when a provider turns off a vehicle, either Tampa doesn't receive that data or that data doesn't come in a form that's easily understandable. So that vehicle might still be sitting in the right of way. It just might be turned off. So it's still taking up the space that's valuable, but it's not being charged for and it's not being tracked. So that is, I think, both like a dashboard capability, but also a question of the data that the city is receiving.
Awesome. That was awesome. That was really great. I just feel like this is like the largest group or set of use cases around this problem that I've seen and yet. Does anyone have any questions and comments about this process? Maybe some ideas about having some of these things actually created. Some of these tools that you might have seen already open source or as part of a third-party product that you all license. Yeah, please chime in. I know we heard from Kyle earlier. Is there anyone else here that is specifically working with the data and trying to take on some of these problems on their own?
I would quickly just add that, so as you could probably guess, I'm definitely more of a back-end guy. And one of the things that I've been trying to facilitate more is trying to avoid having to use some of these third-party products because A, again, they're kind of just greedy for the data, and B, you don't really have full control over what they're actually going to have implemented. And this is kind of also just the front-end portion is something that I'm trying to develop in-house at our DOT, but it's a long, arduous process of getting back into the current state of JavaScript, essentially.
Yeah, can you, I know we're about out of time, but what have been the barriers and what's the opposite of barrier? The throughway to.
Yeah, I mean, I think that the barriers certainly outstrip any of the easy, quick. I mean, there's a couple, I do everything in Python, so there are a couple of nice like Python libraries that do some nice things with leaflet maps, like Folium, which makes my life a little bit easier, but again, you're kind of constrained to what has been implemented. I think my biggest frustration is just kind of figuring out, again, kind of, we don't necessarily have these kind of like top down, like let's wireframe out what everyone actually wants. They kind of just like say, hey, we want something, and are very nebulous about it. And then kind of no matter what I end up trying to implement in like a rudimentary fashion without taking a ton of my time is like not what anyone else envisioned, but it's very hard to kind of like get that unified and like directed information about what the actual final product needs to be. Like I have my own ideas, which I certainly think are good, but other people have other ideas.
Yes, the hardest thing in this world is to try to bridge like the planner domain experts with the technologists. It is probably easier in the business world because everyone can come together on the shared desire to make money. But in our world, we have so many different and disparate bottom lines.
Yeah.
This is a really, this is the challenge. It's what we try to do in the Musa program. So let me, thank you, Kyle. That's really awesome context. I just, I'd love to catch up with you and hear more about this, frankly. But for now, as we close, I want to mention to you all, again, this Musa practicum that we do. If you would like to work with some talented students on some challenging data-driven problems, we would absolutely love to work with you. So we put out the call in August. I have included my email on the last slide of this of the slides. Send me an email. I will send you the call. We work not only in transportation, but as I mentioned, across a whole host of domains. We start putting together the projects in the fall, putting together all the data and building a scope of work so that the students can hit the ground running in January rather, when the semester starts. So we'd love to hear your ideas. We'd love to work with you. Again, thank you for coming and participating. Thank you to NACTO for having us